In the world of machine learning, data is as important as the algorithms written to train machines. But in the industry, it's not always necessary that you will get a well-labeled dataset to work with. So how do you deal with such problem statements where you have huge datasets with millions of data points and there are no labels for you to work with? You deploy clustering, a very important technique in unsupervised learning. And in this exclusive video by Shivam Garg, data scientist at ATLX Labs, he will deep dive into how different clustering algorithms work and their applications with industry examples. But before you start crunching algorithms on your keyboard, make sure you hit that subscribe button and access more premium learning content.
Today we'll be starting with what is unsupervised learning. Then we talk about the k-means clustering algorithm. Then we talk about k-means plus plus clustering algorithm. And then if the time allows, we'll go to the hierarchical clustering as well. Okay. So first of all, let's understand what is unsupervised learning, correct? And how it is related to clustering. So if you remember when you started with machine learning, whether it's linear regression, logistic regression, if you remember before that we studied this concept, correct? That we do have two types of algorithms, supervised and unsupervised. So whenever we say a supervised learning is basically whenever we do have the labeled data set. Labeled data set means where we do have the target column available or target column information for my use case, correct? And then we solve it maybe through linear regression or maybe through logistic regression, depending upon the use case, correct? But in industry, it is not always necessary that we do have a target column definitely in every problem statement. That's not necessary, correct? So those kind of problem statements or those kind of algorithms that we're gonna use in a scenario where target column is not available, that is known as unsupervised learning. And if I give from an industry perspective that what all those kind of use cases, so generally unsupervised learning use cases are those which are like something new in industry. So let's say, for example, let's say I am launching a new product. I want to understand whoso all will purchase it and whosoever will not purchase it. So it's a new product. So you do not have the target column that who will purchase and who will not purchase, correct? Because it's a new launch from the company. So in this situation, you do not have the target column. Similarly, if you want to do the customer segmentation, okay, let's say customers with similar profile, customer with similar habits while doing the shopping, let's say on an e-commerce platform. So depending upon that, you can make the segments of the customer. Customer segmentation, again, one of the example of unsupervised problem only. So supervised learning, you can understand where target column is not available. Like in a supervised, we are having linear regression and logistic regression to solve the problem. In unsupervised learning, clustering is the algorithm or is the algorithm only under the unsupervised. So before that, let's take an example like a use case where we can see how a clustering can be beneficial for the company to segregate or to implement any kind of a solution where we do not have the target column. Remember, don't having the target variable is the primary reason or the primary point where clustering comes to our mind. Okay? Like in industry, you will be having a number of problems. If target column is there, never think about the clustering. Clustering always comes into the picture whenever target column is not available. So let's say, for example, an e-commerce company, let's say Amazon. So you must know that on Amazon, they have like their Diwali sale. On different point of time, they come up with different kind of sales and everything. So now let's say this time Amazon wants to give some customized offer and discount coupons to the customer base. Okay, so they are having three offers currently. They're having, let's say, platinum offer, they're having gold offer, and they're having a silver offer. So that is what they are having. These are the three offers that they want to give. So a platinum offer, there will be 40% off, gold offer, there will be 25% off, and silver offer is having 15%, let's say. Again, this is just an example I'm giving, guys. Now, there are two approaches to tackle this scenario. And what would be two approaches? You can see that written on the screen itself, but still let me read that loud. So even two approaches are there. So first one, they randomly distribute the offers among customer. Like Amazon, let's say having a 10 million base, correct? For that 10 million, they randomly pick that up and distribute the offers among the customers randomly. Okay. Second option or second methodology that Amazon can use, like segment the customer base basis some criteria. They will take some criteria, maybe let's say high value transaction amount, or maybe frequency of shopping, okay, category of shopping, total amount of shopping, average amount of shopping, some amount of shopping, and the frequency in last 3 months, frequency in last 6 months, or maybe how recently a customer has purchased any product. Correct. Let's say on the basis of those criteria and features, we distributed the offer segment wise. What would you suggest to the Amazon? Option one or option two? We will go with the second approach. Why I will go with the first approach? Because if you randomly distribute the offer, don't you think you ended up giving wrong offers to the wrong customer? Maybe a customer is very loyal to the Amazon, he's doing very high transaction amounts, and he's very frequently purchasing and all. And let's say because of random distribution, he got the silver offer. Don't you think it will create a dissatisfaction in the customer's mind? And similarly, let's say one customer who do very less kind of transaction, and he did not even do any kind of transaction recently, and you offer them, let's say, platinum. So it is possible that even he did not use that offer. Agreed? ये भी possible है कि वो offer use ही ना करे. Even he get that, but he don't even use it because he is not that frequent shopper or high transaction value kind of transaction. So now this company wants to make these segments, like which segment we want to offer a platinum offer, which segment I want to offer a gold offer, and which segment I want to offer a silver offer. So now if there would have been a one criteria, अगर कोई एक criteria होता, there would have been, let's say, a single criteria, let's say average amount of transaction, correct? So let's say we can simply solve a problem. Let's say whosoever is having an average amount of transaction greater than 20K, let's go for the platinum offer. If any customer having average transaction amount greater than 10K, let's give them a gold offer. If a customer is having a transaction amount less than 10K, let's give them a silver offer. If can I say that that could be one approach? If there would be a single criteria, average transaction amount, that could be a better approach. But in industry, generally we do not have a univariate problem. You must have seen in linear regression case study, bike sharing assignment. You have seen in lead scoring case study in logistic regression. So do you agreed on that side that problems in industry are not univariate, they are multivariate? And same goes for here. For better decisioning, definitely it should be a multivariate problem, correct? So maybe let's say, for example, average transaction amount you have taken. Let's say you have taken average transaction amount, correct? So guys, is that possible now that a customer may have done the transaction maybe which increases? Absolutely. Age can also be one criteria. So only the average won't suffice. Average transaction amount, age, you can even say location, from which locality it belongs, like north, west, east, west, north, south. And even it could be like frequency of purchase, not only the amount, but the frequency, as well as the recency, that how recently he purchased, and blah blah blah. There could be a number of attributes. Don't you think more attribute we will use, better the segments we will be able to create. Gender could also be one criteria. So keeping all these points in mind, so see, अगर मुझे एक ही पे बनाना होता, if I would have make some decisioning or some criteria on a single feature, so it is a much simpler problem to solve. Correct? With the help of domain knowledge, I would just put some cutoffs, and on that basis, I say, okay, इसको platinum दे दो, उसको gold दे दो, उसको silver दे दो. But in industry, problem is not a single variate. In industry, problem is always a multivariate. Correct? And I hope you also agree with me. Problem should be multivariate only, because more features and more information would be there, better our decision would be. More features we have, better decisioning or better model or better solution we would be able to come up with. Correct? So now, as a human being, do you really think that your mind would be able to find proper cutoffs for all those features mathematically, optimally, manually? Would you be able to do that? No. Our brain is not that sharp that we, हाँ भाई ठीक है, इसका cutoff इतना रख दो, इसका इतना रख दो, मेल में इतना रख दो. You can't do that. You can, but it will not be optimally fine. Agreed? आप कर सकते हो, but it will not be like optimized. Whenever I am dealing with this multivariate problem, I can't optimize it thoroughly. So that's why I'm giving this example again, that we need some algorithm which will do the same task on behalf for me. And that algorithm is only known as clustering algorithm. Now you guys able to connect the dots. So to solve this problem of segment, to classify the customer base into different segments, and we do not have the target column in any problem statement, then we will go for the clustering, because manually we won't be able to make the clusters optimally. You can make, but those will not be optimal. Okay. So, and let me give you one more example, which like I just solved in my company related to clustering only. I just solved like couple of days back only. We just released the solution. So basically, we in my company we have a partner who shared the transaction data with us. Let me tell you the name of the partner also. The name of the partner was Tata Digital. You must have heard about it. Tata Digital basically who sell like this Tanishq, Chroma, Tata Click, Big Basket, MG. All these are the company Tata Digital brand. So now Tata Digital basically shares their transaction data of the customer. Not the transaction data, aggregate features of their transaction data. उन्होंने transaction data नहीं share किया, but they share the aggregated features on the transaction data. The similar like total amount of transaction in last 1 year, total amount of transaction in last 6 months, total amount of transaction in 3 months, total count of transaction in 3 months, count of transaction in 6 months, count of transaction in 12 months, then count of transaction on BB, count of transaction on CL, count of transaction on 1MG, count of transaction in Tanishq, count of transaction in Chroma. So regarding this, they have 250 features. Understood the data? कैसा डेटा होगा? On their platforms, सभी कस्टमर के सब किसी small duration पे transaction amount and transaction count. So basically they have given frequency and the amount, and also they have given the highest value transaction उस platform. Now Tata Digital basically we are into the financial services. So Tata Digital wants to understand that what all customers are high affluent customer, medium affluent customer, and low affluent customer. Tata Digital का जो use case था, the use case is they want to segregate the customer base into 3 categories. And what are those 3 categories? High affluent, medium affluent, and low affluent. Okay, so depending upon them, they can give some offers, a kind of them to their customer base. So don't you think this transaction, whatever features I have given, I have talked about couple of minutes back, those are definitely good enough to decide whether a customer is high affluent, low affluent, or medium affluent. Let's say, for example, if I'm able to see that if a customer is doing a high transaction amount and high frequent transaction on Tanishq, then it is a high value customer. Tanishq, I hope you know that. What is Tanishq? Tanishq is a jewelry brand. Similarly, Chroma. Chroma is also like electronics shopping platform. So now they want to solve the problem to identify high, medium, and low affluent customer basis all segments given. So can we say that like in one go कि भाई ठीक है जो तनिष्क पे जा रहे हैं those will become high affluent, जो तनिष्क पे नहीं जा रहे हो those become low affluent. Would that be a perfect solution? No, it is not a perfect solution. Guys, tell me, is it necessary if a customer is affluent, he will definitely do a shopping from Tanishq? No, I personally never done that. We need to solve it in a multivariate manner. Let's say, for example, if a customer having, let's say, definitely high transaction, again, just giving an example, we need to run a clustering algorithm which will which will maybe segregate customers like this. So maybe we can say that if a customer is having high or medium transaction amount on Tanishq, both of them we can call, let's say, high affluent. But let's say on Chroma side, who is doing the highest transaction, only those I kept into the high affluent. Can I do that? Just say, for example, again, maybe it could be like this. Let me just tell you, guys, this is the industrial problem like we just solved. I'm not creating hypothetically. See, ये तो मैंने hypothetically बनाया था. This example is just created hypothetically. But whatever I'm currently discussing is it is actually an example which we just solved. So let's say we can do like this. Correct. These are the 5 data. So let's say with the help of, let's say, clustering, let's say we are having high, medium, low. There also we are having high, medium, low. Here we are having high, medium, low. So don't you think we can do like this, like just again initial approach, we can do solve this problem with the help of clustering only. Let's say these two are the high affluent. This is the high affluent. This we called as medium affluent. These two we can call as medium affluent. This first one we can call medium affluent, and these two as a low affluent. Can we do that? ऐसा नहीं है कि जिसने we cannot say that जिसने क्रोमा पे तनिष्क पे लो ट्रांजैक्शन किया है तो वो लो अफ्लुएंट है. You can't say that. At least he has done the transaction on Tanishq. So we need to solve this problem in a multivariate manner. You cannot rely on a single feature. You have to consider all of them. That is just what I want to say. And this job is done by the clustering. Don't you think behavior of this high customer will be very similar to these two kind of customers? जरूरी नहीं है कि हाई का हाई के साथ ही होगा. हो सकता है ना तनिष्क के मीडियम अफ्लुएंट कस्टमर का बिहेवियर भी क्रोमा के हाई लेवल कस्टमर से सिमिलर हो सकता है, बिकॉज तनिष्क अपने आप में वुड बी अ वेरी हाई ट्रांजैक्शन अमाउंट. Guys, tell me, are you getting my point? What I'm trying to say? I am trying to say that कि ऐसा जरूरी नहीं है ना कि जो इसका हाई है सिर्फ उसको ही हाई बोलो. लेट मी से इन हिंदी, जो क्रोमा का हाई एफ्लुएंट कस्टमर है उसका बिहेवियर इस मीडियम एफ्लुएंट कस्टमर के बराबर हो सकता है. पॉसिबल है, बिकॉज तनिष्क का हाई ट्रांजैक्शन बहुत बड़ा अमाउंट होगा, लेकिन उसका मीडियम लेवल पे जो कस्टमर होगा वो क्रोमा का हाई कस्टमर हो सकता है. क्रोमा पे इतने बड़े ट्रांजैक्शंस नहीं होते जितने तनिष्क पे होते होंगे. So keeping all that information in mind, end of the day, what I'm trying to say that you cannot solve this problem in a univariate manner. कि भाई ठीक है तनिष्क का हाई है तो हाई, मीडियम है तो मीडियम, लो है तो लो, and you are not considering all other information into the vein. No. You need to solve this problem in a multivariate manner so that you can actually understand the behavior and optimally. And how will you understand the behavior optimally? How will you prove that the behavior of this high segment of chroma will have a similar property or behavior of medium segment of Tanishq? How do you validate that? Again, with the help of clustering. अगर उनका सेम बिहेवियर होगा, क्लस्टरिंग उसको अपने आप एक क्लस्टर में ला देगी. नाउ व्हेन वी से क्लस्टरिंग, नाउ व्हिच क्लस्टरिंग? So basically in clustering, the very popular algorithm that we do have is the k-means clustering. Okay, is the k-means clustering. So k-mean clustering is a clustering algorithm which is used to make k clusters. So for clustering, we need a bulk of data. Like you must have understood, more the data, better the results would be. That is true for every algorithm, correct? Okay. So basically, now let's move to the algorithm in the clustering. And the very first algorithm that we're going to discuss is the k-means algorithm, correct? So k-means algorithm is one of the clustering algorithm. It is an unsupervised algorithm, correct? Everyone is already aware. Now, before jumping onto the k-means clustering algorithm, there is a prerequisite for this algorithm, which is the disadvantage also of this algorithm. Let me discuss the disadvantage right away. The biggest disadvantage of k-means clustering is before actually implementing the algorithm, you should know the value of k beforehand. K is basically the number of clusters कि आपको clusters कितने बनाने. The example I gave you for this Tata Digital, we need to make 3 clusters: high, medium, and low. The example I gave you for that Amazon offer, there also you have to make 3 clusters: platinum offer, gold offer, and silver offer. So basically, before implementing the k-means clustering, we should know how many clusters we want to make. Until unless you don't know the value of k, you can't actually build the algorithm. As simple as that. Correct? Now the question is how to find this value of k. If it is that important, if it is that necessary, then how to identify that value of k? So basically, we are having two methods to identify that. One is the business requirement or a business approach, which will happen in 99% of the cases. In clustering, like two examples we discussed, correct? Don't you think in both of the problem statement, how many clusters we have to make is given in the problem statement only? In clustering, 99% of the time, how many clusters to be made, it is defined in the problem statement only. Means whosoever wants to use that result, जो भी आपके क्लस्टरिंग के आउटपुट को कंज्यूम करेगा, 99% ऑफ द टाइम्स वही आपको बताएगा हाउ मेनी क्लस्टर्स वी एक्चुअली नीड, how many clusters to be needed and to be required, and to be go ahead with the k-means clustering. That number of clusters you will be getting from the stakeholder only. Stakeholder means who will be consuming your output end of the day. Let's say for 1% of the cases, you did not get that number of clusters. They say that decide whatever best works for the data. उन्होंने नंबर ऑफ क्लस्टर्स नहीं दिए, उन्होंने कहा यू डिसाइड एज पर द statistics of the data, correct? For those 1% of the cases, we go with the statistical approach. In that statistical approach also, we are having two methods. Okay, so in statistical, one is the error method, second is the silhouette method. So first of all, let's discuss the elbow method. So in elbow method, on the y-axis, we are having the error, and on the x-axis, I'm having the number of cluster. So now what I'm doing, if you see on the x-axis, I'm having like different values of cluster. दो cluster लोगे तो क्या error होगी? On the x-axis, the number of cluster. On the y-axis, the error. So if you take two clusters, what would be the error? 3 clusters, what error? 4 clusters, what error? 5 clusters, what error? And we plot that curve. So as we keep on increasing the number of clusters, error keeps on going down, and wherever we see this elbow, and whatever point we see this elbow, that my error become almost stagnant, that will become my optimal number of clusters. So in this example, 4 is the optimal number of clusters that I'll be creating for the data set, because at 4, this elbow get created and my error become stagnant after that. So basically, in a layman language, you can say that we are calculating the error at a different values of number of cluster. हम एरर कैलकुलेट कर रहे हैं डिफरेंट डिफरेंट वैल्यूज पे क्लस्टर की, कि 2 लोग हैं तो क्या एरर आएगी, 3 लोग हैं तो क्या एरर आएगी, 4 लोग हैं तो कितनी एरर आएगी, एंड सो ऑन. एंड देन वी सी कि at what value of cluster we able to see an elbow, and after that there is a reduction in error, but reduction is very minimal. एरर रिड्यूस तो हो रही है कि आप अगर क्लस्टर्स बढ़ाते जा रहे हो, एरर रिड्यूस तो हो रही है, बट वी गॉट दैट एल्बो फर्स्ट. अगेन guys, tell me, do you really think in any problem statement we should get 20 cluster, 30 clusters like that? Generally the number of clusters in a problem statement are 3, 4, 5 kind of only. It is not like that we are making, let's say, 50 clusters. Always we need to find how can we minimize the error substantially. So if you see in this example, we able to reduce the error जो 2 पे इतनी थी 2 clusters पे और 4 clusters पे इतनी है, we able to bring the error from there to this point by just moving the clusters from 2 to 4. But let's say further this error come to this point, let's say to this marginally going down, marginally decreasing the error, if you need to move the cluster from 4 to 8, does that make sense? उस marginal error drop के लिए आप number of cluster 4 से 8 कर दो, does that make sense? Absolutely not. So that is what the elbow method is. Wherever we see this minimum error or is like an elbow, that would be considered as my optimal number of cluster. Again, this approach to be used only in those scenario wherever we are not getting the number of clusters from the business, those 1% of the scenarios. Clear? Similarly, we are having this Silote score. Remember, Silote score is a evaluation metric opposite to error. Silote score भी error ही measure करता है, but it is a evaluation metric. मतलब error is a negative term, Silote value is a positive term. Getting my point? Error is a negative term. A negative term means lower the better. Silote score is a positive term, means higher the better. इतना difference है, बाकी it's same only. So definitely curve opposite आएगा. Do you agree with me? If error curve is decreasing with number of clusters increasing, Silote score curve will be opposite. As number of clusters increasing, Silote score will be increasing. Do you agree? Guys, mathematically you agree with me ना? Because जो Silote score है वो error का ही उल्टा है, तो उनका कर्व भी तो उल्टा आएगा ना. Because अगर error घट रही है तो Silote score बढ़ेगा. If error is reducing, Silote score will increase. So that is what they are showing here. Same thing, no difference. We again plotting the number of, we are plotting the Silote score value against every value of cluster. Where we see this elbow, that will become my optimal number of cluster. Clear everyone? Same, but एक में elbow नीचे की तरफ, एक में elbow ऊपर की तरफ. And the reason is again, Silote score is a positive term. तो जैसे number of clusters बढ़ाओगे, वो बढ़ेगी. Error is a negative term. जितनी आप clusters बढ़ाओगे, error घटेगी. Now let's jump on to the algorithm. Guys, this is now like very, very, very important. अभी तक तो we are just understanding what are we studying, why are we studying, and what is the use of that. But now actually the algorithm part comes into the picture. So let's understand the working of the k-means clustering algorithm. Very frequently asked in interviews, and let me tell you frankly, very simple question to answer. Okay, clustering algorithm बहुत आसान है समझना और execute करना comparison to the linear and logistic regression. Okay, so that side you should be like feel relaxed. Let's go to the algorithm. So the very first step in the algorithm is random initialization. So definitely, like I mentioned before, k-means clustering, how many clusters you need is a prerequisite, correct? That I have told you कि number of clusters आपको पहले पता होना चाहिए. That is one of the drawback also of k-means clustering. k-means clustering की ये drawback भी है कि जब तक आपके पास number of clusters नहीं है, you can't train the k-means algorithm. So now what I'm talking about, why the number of clusters are mandatory? Because if you look at the very first step of random initialization, we initialize the centroids of the clusters. And how many centroids we need to initialize? It depends upon the number of clusters we need. If you need 3 clusters, we will initialize 3 starting points. If we have 5 clusters, we have to initialize 5 center points. Agreed? जितने क्लस्टर चाहिए उतने सेंटर पॉइंट डिफाइन करने पड़ेंगे. So if you don't know the number of clusters beforehand, would you able to do this step? अगर आपको यही नहीं पता है कितने क्लस्टर्स हम बनाने वाले हैं, would you able to initialize those many center points? No. So that's why for this algorithm, how many number of clusters you want to make, that is a mandatory thing to know. So very first step over here is we randomly initialize the k centroids. Centroids you can understand like a center of the cluster. Centroid means they are the same thing. Okay, centroid is basically nothing, the center of the cluster. The center of the cluster. So in the very first step, we will randomly initialize k centroids. K means, let's say if you want to make 3 clusters, so 3 centroids. You want to make 5 clusters, so 5 centroids. Okay, in the vector space. Correct? Remember, it is a one-time activity. Random initialization happens one time, the very first time only. Correct? Just to start with some point. Because kahin se to start karna hai na? Just to start from some point, we need this step. Again, it's a one-time activity only. So if you see in this example, whatever, let me just show it again. So let's say we have an example of k equals to 3. So basically, let's say this is your data. Okay. So what we do, what will happen in this step, randomly from anywhere in this vector space. So this is x1 feature, this is x2 feature. Correct? There is no y. Agreed? All the x. Guys, इस बात से तो एग्री करते हो? कोई टारगेट नहीं है ना? There is no y, only the x. It is unsupervised problem. सब x ही है यहाँ पे, y कुछ नहीं है. Okay? So we randomly anywhere, they could be anywhere. Let's say one got initialized here, one got initialized here, one got initialized here. So this become your first centroid, this become your second centroid, this become your third centroid. And this is random. All these 3 are initialized randomly onto the vector space. So the very first step is the random initialization, where we are randomly initializing the k centroids in the vector space. Now the second step is the assignment step. Second step is the assignment step. Now what is this assignment step is? So assignment step, you can understand, we calculate the distance of every data point. If you here you see there are so many data points, we calculate the distance of every data point to every centroid. हर एक डेटा का हर एक सेंट्रोइड के साथ I will calculate the distance. Distance is what distance I am talking about? The Euclidean distance. The distance I am talking about is the Euclidean distance. Let's say this is one data point. If you see here, let's say this is one data point. So for this one data point, I'll calculate the distance with C1. I'll calculate the distance with C2. I will calculate the distance with C3. I will for every data point, हर एक data point के साथ मैं यही करूंगा. For every data point, I will calculate the distance with every centroid. Okay, and I will assign the data point to the centroid which is closest to the data point. So let's assume I just calculate the distance with all 3 of them, and let's say C3, this data point, let's say closest to C3. So this data point will assign it to C3 then. Are you getting my point? What I'm doing? हर एक डेटा पॉइंट का मैं सारे क्लस्टर्स के साथ डिस्टेंस निकालूंगा, और जो भी डेटा पॉइंट जिस भी क्लस्टर के सबसे पास होगा, वो डेटा पॉइंट मैं उस क्लस्टर को असाइन कर दूंगा. फॉर एवरी डेटा पॉइंट I will calculate the distance with every centroid, and that data point will assign to that centroid which is closest among these centroid. जो भी डेटा पॉइंट जिस सेंट्रॉइड के सबसे पास होगा वो डेटा पॉइंट उसी सेंट्रॉइड को असाइन हो जाएगा. एज सिंपल एज दैट. क्लियर? This is the assignment step. Now, updation step. So first of all, random initialization, then assignment. Third is the updation. So updation means, let's say for example, in the assignment step, let's say we are having 5 data points. Just for the simplicity, let's say these are your 5 data points. And let's say you are having 2 clusters, correct? So you are having 2 clusters. So you initialize, let's say randomly initialize. So let's say one cluster initialized here. Let's say your C1, and one centroid, let's say initialized here. Let's say random, let's say C2. So whenever you initialize, so can I say that in the assignment step, this data point will be assigned to C1. This will be assigned to C2. This also will be assigned to C2. This, let's say again C2 is closer, and let's say in this case again let's say C1 is close. Are you able to understand? Assignment में यही होगा, जो डेटा पॉइंट जिस सेंट्रोइड के पास होगा वो उसको असाइन कर दिया जाएगा. करेक्ट? So now what will happen? This become kind of one cluster. This become kind of another cluster. Agreed? ये दो क्लस्टर बनेंगे. Now what will happen in the updation step? I will calculate this C1 again. Let's say this is X1, this is X2. This is, let's say, data point 1, this is data point 2, this is data point 3, this is data point 4, this is data point 5. So for every data point, we are having X1 and X2. Correct? सारे डेटा पॉइंट के कुछ वैल्यूज होंगी X1 and X2 की for every data point. Let's say for D1, this is 10, 20, 40, 50, 70. So let's say 10, 20, 40, 50, 70. Similarly, on the Y side, let's say this is 10, this is 8. Again, I'm just taking dummies, nothing much. Okay, let's say this is 20. All three of them same. So let's say D1 is having 10, D2 is having 8, and let's say all these are having 20. Correct? I just created the data, nothing else, correct, from the graph. So now this new centroid, so basically this is assigned to C1, these two are assigned to C1, and these three are assigned to C2. Agreed? Now what will happen? New centroid C1 dash, इसके भी दो कोऑर्डिनेट होंगे x1 and x2. Let's say currently it is 6, 10, 6. Similarly, C2 के भी it would be 40, let's say 25. Can I say that currently these are the coordinates of C1, C2 currently? Again, मैं सिर्फ ग्राफ से एक डमी वैल्यूज उठा रहा हूं. करेक्ट? नाउ आई नीड टू अपडेट. तो centroids are updated with the mean of all the data points assigned to that centroid. These centroid values needs to be updated with the average of the data points assigned to them. So C1 will become 10 plus 20 ka average, that is 30 by 2, 15. So this 10 will become 15, and this 6, 10 or 8, 18, and this will become 9. Similarly for C2, 40 plus 50 plus 70, 7, 5, 12, 12 or 4, 16, 60, and 60, 160 divided by 3, which is 53 point something. this will become 53, and this is 20 20 20, so this will become 20. So my new centroid values would be C1 dash would be 15, maybe somewhere here, and 9 means it will become somewhere here now. C1 dash, this centroid moved from this to this location, and C2 dash 53, maybe somewhere here, and 20 means somewhere here it will be. It will move from here to here. See, this is known as updation. Are you able to understand that? Now my previous centroid, though, so this no more a centroid now. So now these are my new centroids. So new centroid will be the average. That's why again, name of the algorithm is k-mean. Why this mean has been given? Because of this average of update logic only. Are you able to relate? Algorithm का नाम k means क्यों रखा गया है? K because the number of clusters, and means because all these clusters are calculated as an average of the data points assigned to that cluster. That's why the name of the algorithm is k-means algorithm. Correct? So now what will happen? Now we have the updated centroid. Now again, we free them from the cluster. Now what we will do? We will again repeat the step number 2 of assignment and updation. We will repeat the step of assignment and updation until my centroid stop moving. So what I will do? I will again calculate the distance. मैं क्या जो नए centroids आए, guys tell me, my centroids has been moved. So उनकी distance भी data point से change होगी. Their distance will also get changed with the data points because they have changed their position. Now new values of centroids has changed their position, and if their distance got changed, so it is possible that कि जो data point पहले C1 में आ रहा था वो C2 में चला जाए, and vice versa. Is that possible? Absolutely, yes, it is possible. So what we will do? Again, we will assign the data points. Again, we will assign the data point with the same logic. हम हर एक data point को दोबारा से distance calculate करेंगे. We'll calculate the distance of every data point again, and I will try to assign it again, and we'll again do the updation. And we keep on doing this like 2 times, 3 times, 4 times. We'll keep on doing this step again and again. We will assign, update, assign, update, assign, update. And definitely we have to stop somewhere. We will stop when clusters में जो data point assigned है वो next step में किसी और को assigned नहीं हो रहे. Means your clusters become stable. I'm repeating this line. हम repeat तो करते जा रहे हैं, assignment, update, assignment, update, assignment, update. We keep on repeating assignment, update, but we have to stop somewhere. कहीं तो रुकना पड़ेगा ना, infinite loop में थोड़ी जाना है. We do not want to go to the infinite loop. We have to stop somewhere. But where will you stop? We will be stopping our clustering algorithm where my data points stops moving to other clusters. सोचो अगर guys मेरे data points ने centroid cluster change करने बंद कर दिए, तो क्या मेरे centroid के updation step में कोई change आएगा? Let's say for example, let's say मैंने इसको दोबारा रन किया और D1, D2 अभी भी C1 के साथ ही है, D3, D4, D5 अभी भी C2 के साथ ही है. क्या मेरी C1 और C2 की वैल्यू फर्दर अपडेट होगी? अब अगर क्लस्टर मूव ही नहीं किए, अगर डेटा पॉइंट शिफ्ट ही नहीं हुए, and then it shows I have to stop there. Whenever the data points from other clusters stop entering the cluster, then we can stop, right? Absolutely correct. And why so? Because if data points stops moving from one cluster to another cluster, आपके सेंट्रोइड अपडेट ही नहीं होंगे. इवन इफ यू आर रनिंग, उसके बाद अगर एल्गोरिथम आप चलाते भी रहो, देयर इज नो चेंज इन द आउटपुट. एग्रीड? बिकॉज आपका सेंट्रोइड चेंज नहीं होगा तो आपकी डिस्टेंस चेंज नहीं होगी, डिस्टेंस चेंज नहीं होगी तो असाइनमेंट चेंज नहीं होगा, असाइनमेंट चेंज नहीं होगा तो अपडेट नहीं होगा. एंड इट कीप ऑन rolling. So we have to stop. What is the stopping criteria in k-means algorithm? An answer is very simple. Whenever my data points stop shuffling from one cluster to another cluster, it shows that clusters are ready. Because if data points are not shuffling from one cluster to another cluster, means assignment is not changing. If assignment is not changing, means update is not happening. If update is not happening, distance will not be changing. And once distance will not be changing, assignment will not be changing. And this becomes a loop. So whenever my clusters become stable, stable means data points are not changing the clusters, we can stop the algorithm to train. If I summarize, so k-means clustering is a 5-step process. First of all, calculate the number of clusters, maybe from business or maybe statistically. Second, random initialization. Third point, assignment. Fourth step, you can say update. You need to update the centroids as per the data point assigned. And finally, the repetition. We will keep on repeating the assignment and update step until we got the stable clusters. Until we got the stable clusters. Okay, guys, take a read, which is available on your screen. These 3 steps.
If you have stayed till here, that means you are determined to crack this concept. You should check out our industry-ready courses in machine learning and artificial intelligence from top universities in India as well as abroad. Link is in the description. Now, back to coding.
So basically, we are having 2 algorithms, k-means and first of all, let me tell you, both the algorithms are same. Only difference in the random cluster center initialization. Remember, this was the step 1 in your algorithm, random initialization. Agreed, random initialization is the very first step in your algorithm. Wherever we are randomly initialize the k centroids, that is different in both of them. In k means, let's say you are having k equal to 3. So let's say this is your data. Let me just checking. Let's say I'm having this data. Okay, same data only. Okay, same data only. So if you see here, whenever you are initializing for k equal to 3 here, in case of k means, randomly 3 centroids are initialized. Let's say C1, maybe C2, maybe C3. Correct? They could be anywhere. Agreed? ये कहीं भी हो सकता है वेक्टर स्पेस में. Agreed? तो जब ये कहीं भी हो सकते हैं वेक्टर स्पेस में, सो इज दैट अ पॉसिबिलिटी कि 2 सेंट्रॉइड बहुत पास पास हो जाए? एब्सोल्युटली है, बिकॉज इट इज कंप्लीटली रैंडम. वो तो कुछ और चेक ही नहीं कर रहा, वो तो रैंडमली इनिशियलाइज कर रहा है. करेक्ट? बट डू यू रियली थिंक क्लस्टर्स पास पास होने चाहिए? नो, क्लस्टर शुड बी फार्दर. एब्सोल्युटली. सो आर यू एबल टू सी अ प्रॉब्लम? सेकेंड पॉइंट is that it is also possible that कि एक क्लस्टर कोई, जैसे ये पूरा वेक्टर स्पेस में डेटा है और एक क्लस्टर को यहां जाके असाइन हो जाए. इज दैट पॉसिबल? डेटा तो सारा वेक्टर स्पेस की इस रेंज में है, बट कोई क्लस्टर बहुत दूर जाके असाइन हो जाए. पॉसिबल है, रैंडम है ना. इट कुड बी एनीवेयर गाइस, इट इज रैंडम, इट कुड बी एनीवेयर. So to solve these problems, to solve these 2 problems, one problem is none of the clusters should not be like very far away from the data point, because it will take more iterations. इसको बहुत ज्यादा iterations लगेंगे इस range में आने के लिए. You have to do so many updation and repetition to bring it into the range. So what is the solution for this? The solution for this is k-means plus plus. And what is the solution? Simple. First of all, they say that rather than randomly initializing the data points on a vector space, आप clusters तो 3 ही assign करो, but assign them from the data point only. Listen me properly. What they are saying, create these centroids rather than from infinite options available on vector space. Whatever data points are available, इन्हीं data points में जो centroid बना दो. Can I say that creating data points itself as a centroid be able to solve that problem? कि कोई भी सेंट्रॉइड डेटा रेंज से बाहर नहीं जाके इनिशियलाइज होगा? आर वी एबल टू सोल्व दैट प्रॉब्लम? फर्स्ट एक प्रॉब्लम अभी दो देख, सी लेट मी रिपीट. सो देर आर टू प्रॉब्लम्स. One problem is any of my cluster is initialized very far from the data. Second problem is two clusters initialized very closer to each other. दो problem थी. So first problem is addressed. First problem is addressed by making data points itself the centroid. या randomly तो बनाना है, आप infinitely explore मत करो. जो डेटा पॉइंट्स अवेलेबल है रैंडमली, अगेन आई एम नॉट फिक्सिंग इट, अगेन रैंडमली ओनली उन्हें डेटा पॉइंट में से एक सेंट्रॉइड बना दो. उससे मेरी पहली प्रॉब्लम सोल्व हो गई, विच सॉल्व्स माय फर्स्ट ऑफ माय प्रॉब्लम, दैट सेंट्रॉइड्स विल ऑलवेज इनिशियलाइज्ड विद इन द विसिनिटी ऑफ द डेटा. करेक्ट, क्योंकि मैंने डेटा पॉइंट को ही सेंट्रॉइड बना दिया, मैंने डेटा पॉइंट को ही सेंट्रॉइड बना दिया. So everything will get initialized in the vicinity of the data only. Can I say that first of my problem is solved? Now coming to the second problem. अब जब ये डेटा पॉइंट को सेंट्रॉइड बनाते हैं, they don't do it like this. वो भी ये स्मार्टली करता है. कैसे? Let me tell you. वो क्या करेंगे, सबसे पहले एक सेंट्रॉइड को रैंडमली इनिशियलाइज करेंगे. मींस पहला फ्रॉम द डेटा पॉइंट ओनली, जैसे आपके पास 1000 डेटा पॉइंट है, उन 1000 में से रैंडमली किसी एक को पहला सेंट्रॉइड बना देंगे. फ्रॉम दोज n नंबर ऑफ डेटा पॉइंट्स रैंडमली दे विल मेक वन डेटा पॉइंट एज सेंट्रॉइड. देन सेकेंड सेंट्रॉइड विल बी डिसाइडेड इन सच अ वे विच इज फारदेस्ट फ्रॉम C1 अमंग दीज डेटा पॉइंट ओनली. इन सारे डेटा पॉइंट्स में से जो डेटा पॉइंट C1 से सबसे दूर होगा, लेट्स से दिस वन, this will be known as C2. Are you able to understand? उन्होंने C1 को तो रैंडमली असाइन किया, बट C2 वो ऐसे असाइन करेंगे उन डेटा पॉइंट्स में से जो डेटा पॉइंट C1 से सबसे दूर होगा, उसको वो C2 बनाएंगे. एग्रीड? एबल टू फॉलो मी? और C3 लेट से तीसरा क्लस्टर भी बनाना है, वो तीसरा ऐसा बनाएंगे जो इन दोनों से ही सबसे दूर होगा. लेट से दिस. रिपीटिंग वन मोर टाइम, जो डेटा पॉइंट्स है पहली बात वही सेंट्रॉइड बनेंगे. दैट इज क्लियर. वेरी फर्स्ट पॉइंट, नवीन रिपीटिंग ऑलरेडी. सो वॉट एवर centroids, so first centroids, it's randomly selected from all the data points. It could be any one of them. But second centroid will be the data point which is farthest from the first centroid. And third centroid will be the data point which is farthest from the first. This way we are able to tackle the second problem as well, that none of the centroids are initialized very closer to each other. Again, the assignment step, the updation step, and rest of the steps are same. No change on that side. Those steps are exactly the same. The only change in the initialization step. And to overcome the problem that we were having in the k-means. So if somebody asks you what is the difference between k-means and k-means plus plus, would you able to easily explain and define? So simple, rest of the steps are same. The only problem with the random initialization. In k-means, all the data points are, all the centroids are initialized randomly in one go. But in k-means plus plus, first centroid is randomly selected as one of the data point. Then rest of the centroids are selecting. Let's say second centroid is selecting with the data point which is farthest from first centroid. Third centroid is selected which is farthest from C1 and C2 both, and so on. And so on. That is the k-means plus plus. So let's see an example if you want to see. See here. So let's say you randomly select. First, let's say you have k equal to 3. Again, this 3 number will be coming from your prerequisite only. Let's say from there 9 data points are there. We are having 9 data points. From these 9 data points, randomly, one will become your C1. Let's say randomly, this data point is selected as C1. Randomly. Now what I will do, Now I will calculate the distance of this centroid with all the data points. And I find that, let's say this one is farthest from this. This will become my C2 then. Are you getting that? How I assigned C2? Because that is the data point जो C1 से सबसे दूर था 9 data points. C2 is the point which is farthest from those out of these 9 data points. Now let's say I made this point as C3 because this is farthest from C1 and C2 both among all these 9 data points. Done. Rather than randomly initializing, I am doing this in K-means plus. In general, how much computation cost is saved by using K-means plus? More than 90%, brother, you can say that. K-means plus makes K-means algorithm much faster. Because see, understand, like you have limited the scope. First of all, you are allowed to initialize the centroid anywhere in the vector space, kahin bhi. So definitely it will be effortful. And let me tell you, nobody uses K-means. Everybody uses K-means plus only. Mark my line. Nobody uses K-means algorithm. Everybody uses K-means plus only. Even, let me tell you, in the library, the name of the library is K-means. But the algorithm running in the backend is K-means plus only. By default. It does not. It makes sense, na? If any algorithm is giving you 90% runtime saving and performance, we should use K-means plus only, correct? There's no point in using the K-means. But yes, why we are studying K-means? अब आप सोचोगे जब K-means plus ही use कर रहे हैं तो why are we studying K-means? Because that is the core algorithm. K-means plus just change the initialization. But the core algorithm is given by K-means only, correct? So that is the reason over there. Now the question, if first and when we center all the data point, will it work efficiently? Yes, at that point, yes, it would be less efficient at that point in time. If it is definitely the center of all the data points, yes, it will be little less efficient in that scenario. But again, that is one of the scenario out of so many. So next clustering that we do have is the hierarchical cluster. So like I mentioned, in K-means clustering, there is one disadvantage, which I mentioned in the starting itself. The disadvantage of K-means clustering is number of clusters you should know beforehand. In hierarchical clustering, this is opposite. Here, first you train the algorithm, and later on, as per the results, you decide how many clusters you need. In hierarchical clustering, we do not need number of clusters beforehand. We first train the algorithm. सबसे पहले हम एल्गोरिदम को ट्रेन करेंगे, and once the algorithm is ready, then we will decide how many clusters would be good enough on the basis of the results. So hierarchical clustering is actually overcoming that problem that we are having in K-means clustering, that we would be needing the number of clusters to be defined beforehand. In hierarchical clustering, that is not the scenario. In hierarchical clustering, that is not the scenario. Okay, so how this algorithm actually works? So let's say you are having the data points. Okay, let's say you are having these 5 data points. Let's say this is A. Now here what will happen, guys, please listen me properly. It is easy, but again, maybe something new for you. Here what we will be doing, we will be calculating the distance of all the combinations. All the combinations means like this. A to A distance is 0. Diagonal will be 0. Agreed? Everyone will have the 0 distance from the same data point. A का A के distance is 0. B का B के साथ 0. C का C के साथ 0. Correct? Now I'll calculate the, let's say, distance of A and B. Let's say this is 2 unit. Distance of A and C. Let's say this is 4 unit. A and D 5 unit. Let's say A and E. Let's say 7 unit. Then I'll calculate B ka. B ka A, let's say 2 unit only. B ka C, let's say 3 unit. B ka D, again, let's say 4 unit. B ka E, let's say 5 unit. Again, This is Euclidean distance only, guys. Currently, I'm just filling with the dummy values, but these are the Euclidean. Are you getting now how I'm calculating the distance? Euclidean distance only from these two data points, nothing new. Okay, this would be 2, 4, correct? Now C ka D se distance, let's say 2 unit. C ka E se let's say 3 unit. Okay, D ka A se let's say 5. D ka E se let's say 1 unit. Now we can say that 7, 5, 3, 1. Correct? ये distance metric बना सकते हैं. We can make this distance metric distance of all the data points with all the data points. Correct? Now tell me which two data points are closest as per the distance metric. Which two data points are closest as per the distance metric? Absolutely, DE are the closest if you see here. So what we do, we will merge them. Able to understand? Now these two will be considered as single entity. Okay, now new distance metric. Now new distance metric. Okay, so let's say A, B, C, and DE will be considered as together now. Are you able to understand that? This is how this hierarchical clustering works. This is how hierarchical clustering works. So guys, so far so good. Are you able to understand? Now DE will be considered as single. Now DE will be considered as single. Now what we will do? Again, A to A distance 0, A to B 2 unit, A to C 4 unit, A to D. Now the question, how will you calculate the distance of A to D? So there are 3 distances possible. One distance is this. Okay, basically there are 2 distances possible. There are 2 distances possible. One is AD, one is AE. Can I say that 2 distance possible? Guys, tell me. No, Indu, that is not we are making. It is not K-means algorithm. We are not making centroid. These two will be considered as single, Indu. That is what I am talking about. हमने इन दोनों को मिला के कोई एक centroid नहीं बना दिया है. These two are 2 data points only, but will be considered as single entity now. Correct? Now I need to calculate the distance. So there are 2 distances possible, A versus D and A versus E. Correct? So here 3 things are possible. इन दोनों में से जो मैक्सिमम है वो ले लो, इन दोनों में जो मिनिमम है वो ले लो, or either take the average. Either take the maximum of these two, either take the minimum of these two, either take the average of these two. Correct? All these 3 are possible. All these 3 could be possible scenario. So this is which one you will be taking. It depends upon your linkage. In hierarchical clustering, there is a concept of linkage. Okay, we are having linkages here. On the basis of linkage, we basically decide how to basically go ahead. So basically, if I talk about the linkages, so in hierarchical clustering, we basically have 3 kinds of linkage: single linkage, complete linkage, and average linkage. If I say, if you are taking the minimum distance out of these two, jo bhi minimum ho, if you are taking a single linkage, then it will consider the minimum distance. If you are using complete linkage, it will be taking the maximum distance. And if you are using the average linkage, it will be taking the average of these two. Are you able to understand that? Depending upon your linkage, that distance will be considered between these 2 data points. Repeating one more time. In the previous step, I found that D and E are the closest one. So these 2 will be considered as single entity now. So after considering this single entity, and whenever I will be creating the distance metric again after merging them, so whenever I'm calculating the distance of these single entity with A, B, C, or whatever data points. So multiple distances would be possible. Out of those multiple distances, आप minimum लोगे, maximum लोगे और average लोगे. Whatever you will take, minimum, maximum or average, it will depend upon the type of linkages. If you are taking a if again, this is something which you have to define beforehand, which is a hyperparameter. Hyperparameter means you can understand like which is there is no right and wrong answer to this. Means you have to experiment that whether single linkage is giving you the better results, complete linkage is giving you the better results, or average linkage is giving you the better results. We cannot say that single is better, complete is better, average is better. No, we have to try as per your data which is working best. Okay, but most of the scenarios in industry, complete linkage works best, correct? But yeah, again, you need to validate or as per the requirement of your data, correct? Once it is done, so here let's say we are taking the let's say single linkage, the minimum distance. Let's say AE is the minimum, so AE, let's say we say that it is 7 units. Okay, now again for BA2, again diagonal will be 0. Now B versus C, we calculated previously, same, let's say 3 units. B versus D, again now I need to calculate B versus DE, same funda. B versus D I will calculate, B versus E I will calculate, and I'll take the minimum of these two. Guys, these are the straight lines. Don't go with my drawing. Again, let's say we are taking the minimum, so BD is the minimum. So here we are taking, let's say 4 units. Now CA would be 4 we have taken, CB we have taken 3. Now again, we'll do the same with the CD. Now we'll again do with this. So again, C with the D and C with E. Again, this is the minimum. Let's say it is 2 units. Okay. So are you able to understand how this new distance metric will get created? Now you understand how this new distance metric got created. Now tell me which I should merge now. So guys, now we are having 2 options, I believe. We can merge AB also, and we can merge CDE also, correct? Both options are there. Guys, you can use any one of them. You can join any one of them, correct? So let's say I'm using AB. मैं थोड़ा complex कर लेता. Clear everyone? आप दूसरा option भी ले सकते थे. Both are correct. It's random because both are same. So you can use any one of them. Okay. So now again this distance metric will be calculated. This time it would be like this. AB, C, DE. AB, C and DE. Agreed everyone? This would be our new metric. Now again we will calculate the distance of C with, so again इसका इससे निकालेंगे, इसका इससे निकालेंगे. Whatever the minimum, CB is minimum, we let's say 3. Then similarly, either also we do the same. We'll calculate the distance of CD, we'll calculate the distance of CE, which is let's say 2. Okay. Then again, this would be again 3 only. Now we'll calculate distance of, we will calculate the distance of C with the DE, which is again 2. And then we'll calculate the distance of DE versus AB. Now we'll calculate the distance of, sorry, my bad. We need to calculate here. We need to calculate the distance of AB versus DE. So 4 distances possible, guys. Yes or no? 4 distance possible hai? 4 distances. Again, all the combinations, jo bhi banenge. All the combinations, among all of them, whatever is minimum, because we have taken an example of single linkage. So whatever is minimum among all of them. So let's say minimum is BD. Okay, which is let's say 4 units. Okay, so this will be 4. Okay, now C versus D we calculated 2. Now tell me which I should merge now. Now I should merge CD and E. So I should merge this. Okay. Now this will become AB and CDE. AB and CD. Now in the last step, do you feel that we need to calculate the distance or we can directly merge these two? Do we have any options now? टू मर्ज करने के लिए क्या हमारे पास ऑप्शंस हैं अभी? नो, वी लेफ्ट विथ 2 ना, तो लेट्स डायरेक्टली मर्ज. In that case, we can directly merge now. Okay. Now see what we just did. So you have 5 A, B, C, D, E. First of all, can I say that I merged D and E? Agreed? सबसे पहले मैंने D और E merge किया था. So what will happen in the dendrogram? Then I merge A and B. Then I merge C, D and E. Then I merge these two. Are you able to understand how this is getting created? This is known as dendrogram. Repeating one more time. First of all, in my hierarchical clustering, I merge these two. If you remember, पहले मैंने इन दोनों को merge किया. Then I did merge A and B. Then इसके साथ C merge हुआ. Basically, first of all, I merged DE, then AB, then C got merged with the DE, and finally, this happened. And this is known as dendrogram. This is known as dendrogram. Now you can decide, let's say for example, how many clusters you need. So you need 2 clusters. So you will, if you need 2 cluster, so this will become your 1. If you need two clusters, just create a line which is cutting 2 lines. So this will become your 1 cluster. This will become your second cluster. Now let's say you need 3 clusters. Now let's say you need 3 cluster, and cut the dendrogram from here. This is 1 cluster, this is second cluster, this is third cluster. Are you able to see that we are having a flexibility? Are you able to see that? हमारे पास flexibility है. We are not fixed कि नहीं, we have to make 3 cluster, 4 cluster, 2 clusters. No. Whatever clusters you want, we can do that. Let's say we need 4 clusters. Okay. Let's say in this case, you will be needing 4 cluster. 4 cluster in this scenario won't be possible because if you see, these two are coming at the, again, here also you can say that if you see like this, so this is 1, this is 2, this is 3, and this is 4. I mean, this is 1 cluster, this is 1 cluster, this is 1 cluster, this is 1 cluster. So we have that flexibility in this. We are having the flexibility in this dendrogram. As per my requirement, I can design the clusters. That is the beauty of hierarchical clustering. Is that clear to everyone? Able to understand how hierarchical clustering is different from k-means clustering? So hierarchical clustering is surpassing the importance and the usage of k-means clustering by not making it compulsory to have the number of clusters beforehand. In k-means, you cannot move ahead without knowing the number of clusters. But hierarchical clustering, you have seen the example. In hierarchical clustering, do I have decided already how many clusters I need in the starting? Have I told you I want to make 2 cluster, 3 cluster? No. But once we have the outcome on the basis of this diagram, which we called as dendrogram, whether I need 2 cluster, 3 cluster, 4 cluster, I can merge. That flexibility I'm having. My algorithm is trained in a generic manner. My hierarchical clustering is available in a generic manner. Now, as per my requirement, how many clusters you need, I can, guys, tell me if my number of cluster, let me tell you the biggest advantage. Let's say business team today told that I need 3 clusters. But after 1 month, they realizes, oh, we need 4 clusters, not 3. So don't you think in k-means you have to retrain the complete algorithm again? If your number of cluster changes in k-means algorithm, you have to retrain your algorithm because there's a change in the very first step only. उन्होंने सबसे पहला स्टेप ही चेंज कर दिया. They have changed the very first step itself. Definitely second, third, fourth, fifth, every step will change. But in hierarchical clustering, if they change, I don't want 3 clusters, I want 4 clusters, do you need to do any kind of rework? No, you will just say that, rather than cutting the dendrogram from this point, cut the dendrogram from this point. So previously you are considering AB. Whenever you say three clusters, you are giving them these three clusters, A, B, C and D. Now they will ask, oh, I need four clusters. You will say, ठीक है भाई, no problem. Consider A and B separately. Is there any extra effort or retraining or something? No, we can directly consume the previous result itself. Definitely it is difficult to see the dendrogram whenever there is a huge amount of data. Yes, that is a challenging stuff. But yes, it is a pictorial representation, so it is not that even that difficult as well. Okay. Can you please repeat how do we decide when to stop clustering in hierarchical clustering? Once everything become a single cluster, you can stop there. See na? In the last we merge all of them together and stop. Once everything becomes single, you have to stop. How to find the optimal cluster number in hierarchy? As per the requirement only. Here what you need to see, as per the requirement, you have to see the behavior. Let me show you. So this dendrogram basically gives you an idea that how clusters are different. So basically what will happen, see, again in front of you only, if you see that this height of C cluster merging with CD, if this height is really more, it shows that behavior of C is very different from D. This could be like this also, na? This is also possible like this. And what does that mean? That behavior of C is very similar to D. If that distance, whatever height of dendrogram, if it is more, means these two are having a different behavior. So if you are having this kind of a scenario, it should be considered together. And if that is the scenario, it should be considered as separate. So that is how dendrogram will help.
If you have stayed till here, that means you are determined to crack this concept. You should check out our industry-ready courses in machine learning and artificial intelligence from top universities in India as well as abroad. Link is in the description. Now, back to coding.
Everyone, please be ready with the Jupyter notebook at the year end. We will be having a clustering live coding session. First of all, let's start with importing the libraries. Meanwhile, let me share the data with you. Okay, please import the libraries. So basically, I'm importing a basic one, importing pandas and numpy. Okay, for data analysis and numerical analysis, matplotlib and c1 for the visualization, and finally the warnings. Over to you guys. Once we guys are able to load the library, the second thing is we need to load the data set. Please load it in the Jupyter notebook. Then we'll brief about the problem statement. Okay, so first of all, let me brief you about the problem statement that we are trying to solve over here. The simple problem that we are trying to solve over here is we need to segment the countries into the three categories. Basically, we need to segment them by saying we need to categorize the country on the basis of their economical indicators. Hey, are you able to see that? So first of all, the column is country, the country name. Then we are having a variable known as child mortality. So all the child mortality, export, health, import, income, inflation, life expectancy, total fertility, GDPP, all these are the economic indicators, correct? Don't you think these features will definitely help me to understand the developing behavior of the country, whether it is a developed country or an underdeveloped country or a developing country, with the help of these parameters? So basically, first of all, whenever we start with any of the project or any of the data set, the very first thing you should be able to understand the data. So here we received country column, 167 countries are there. If you check how many unique countries is there, so each row here represents one country. So we are having total 167 rows and total 167 unique countries. So each row represents one country data. Okay, and it represents their macroeconomic behavior. So for example, if I talk about child mortality, so child mortality basically represents the number of child dies under the age of 5 because of malnutrition. I hope you are aware about this terminology, child mortality. because of unavailability of nutrition, proper food and stuff, child dies before the age of 5. That is considered a child mortality. Then export is basically the percentage of GDP this company is spending on export. So when you say 10, it means 10% of GDP expenditure in export. Health, 7.58 percentage of GDP in health. 44.9% of GDP is included in import. So export, health and import, these three columns are the percentage of GDP that is to be expended on export, health and import respectively. Then income is the per capita income of the citizen in that country. So Afghanistan has 1610 rupees as a per capita income. Then inflation, everybody knows inflation. Life expectancy is basically the average amount of age a people is living in that country. Like in India, it is around 64, 65 age. In USA, it is around 75, 80 years. Okay. So life expectancy is the average life of a citizen living over there. Total fertility is a number of children per woman. So in Afghanistan, there are 5.82 children per woman. In Albania, it is 1.65 children per woman. So total fertility is a kind of number of children per woman. And finally, GDPP. GDPP is GDP per person. I hope everybody knows GDP, gross domestic product. So GDP per person. This is the information given over here. So can I say that these data are the indicator of the development or of the growth of the country? So let's say, for example, if the GDP is high, definitely a country is good. Inflation is low, life expectancy is high, child mortality is low. Yeah, these are the economic indicators, correct? So basically, with the help of these economic indicators, what we need to do, we need to categorize the countries on the basis of their economic indicators. So now the first question is, so see, it is already, we will say that is a clustering session. So definitely we'll solve a clustering problem. But in industry, it is not like that. Whenever you get a problem statement, you have to think whether it is a supervised problem or whether it is an unsupervised problem, correct? वहां थोड़ी कोई बताएगा क्लस्टरिंग सेशन है तो क्लस्टरिंग की प्रॉब्लम होगी. There you have to figure it out. So how will you figure it out? Here you want to predict whether a country is developed country, underdeveloped country or developing country. So do we have any column in the data set which is telling me a country is developed, underdeveloped or developing directly? No. So we do not have any labels. We do not have any direct labels available in the data which tells me it is an unsupervised problem. So as there is no target column, it is an unsupervised problem. Hence, we can use clustering algorithm, or you can say we can use k-means clustering algorithm. Correct? So let's say, for example, let's compare one of the best country, which we called. Let's compare few countries, which with that, again, as I told you, in clustering, common sense, business knowledge plays a very important role. So let's compare three countries: developed, underdeveloped, or developing country. So for developed, I'm taking United States. For developing, I'm using India. Again, currently, I'm not fetching it from data. I'm using my domain knowledge to understand the data, whether data has some power or not. Let's take some underdeveloped country. For underdeveloped, you can take, let's say, Pakistan. Okay. Now tell me, are you just go through these cells properly? We can take Afghanistan also simply. That is also correct. Just guys, go through all three of them. You will see whatever the positive indicator, those will be having a very high value in United States, medium value in India, and very low value in the underdeveloped country. And whatever the negative indicator, you will see highest in underdeveloped country and minimum in the developed country. So for example, see, guys, tell me, child mortality is a positive thing or a negative thing? Child mortality is a positive thing or a negative thing? It is a negative thing, correct? So you can see that it is a negative thing. That's why it is minimum in United States, but it is very high. It is highest in the Pakistan. Similarly, export. Again, guys, export, health, and import are not the correct numbers because they are in the percentage of the GDP. So we should calculate these numbers in the actual terms. Currently, what you're able to see that it is 12.4%, it is 13.5%. But can we compare them? No, because they are the percentages of GDP. ऐसे तो देखने में पाकिस्तान का ज्यादा लग रहा है. But if you go into the absolute term, then you will realize what are the actual numbers are. So I'm calculating the actual export by calculating the export multiplied by GDP because they are the percentage of GDP. So I'm calculating their actual numbers. Now, are you able to see the difference? Kitna difference hai? See, our percentages mein it is bluffing us. So that's why we need to convert these features into their exact value. Now see, health, US is expending this much on health, but Pakistan is spending this much on health. Similarly for import, similarly for income, inflation, life expectancy, total fertility, GDP. Tell me guys, are you able to see a clear distinction into a developed country and a developing country and underdeveloped country with the help of these economic indicators? There is a distinction. So we do have a good enriched data to segregate developed, underdeveloped, and developing countries. Okay, so over to you guys. First of all, please convert these columns into their actual values rather than percentages. Then check the explore these three countries at your end. So are you guys able to see the distinction between these categories on the basis of features? And not only one, most of the features are inclined towards that. Okay, so now let's move ahead. So once we able to do all this kind of pre-processing, now let's check for the missing values. Now let's check for the missing values. So there are no missing values in the data, but if there would have been any missing values, you know guys how to take care of that, correct? So please check for the missing values. So check for the missing values. But again, guys, do not assume there would be some different strategies or different methods to take care of missing values. Absolutely not. The methods for imputing or taking care of missing values is the same like we do in our conventional machine learning algorithms. Nothing new. हमें countries को divide करना है on the basis of their features. So country is like a index to us. It is not a feature. So what we need to do, so I'm dropping the country column from the data set. But do you think that country column is completely irrelevant to us? It is not relevant to modeling, but it is relevant to the use case, correct? उसे modeling में जरूरत नहीं है, but it is required end of the day once we are done with the clustering to segment the countries, correct? That's why I'm not dropping it actually. Basically, I'm dropping it and creating a new data frame which I will use for modeling rather than dropping it from the original data set. So I'm keeping it in original data frame, but I'm creating a new data frame without country column that will be used for modeling. Because मैं original में से drop कर दूंगा तो difficult हो जाएगा because I need it later on. So these are my features finally. And next step over here would be we would be doing the scaling. As I mentioned yesterday as well, scaling is a mandatory thing to do in a clustering problem. Okay, so we are doing the scaling. So for scaling, min-max scalar is sufficient. Standard scaling is not required. So from sklearn.preprocessing, I'm importing the min-max scalar, defining its object, and passing it to the df1. So df1 is my data. I'm doing the fit transform. So I'm doing the scaling, and this is your final scaled data. And this is your final scaled data. Scaling is very important in clustering because let's say, for example, can you calculate the distance, let's say, between a salary of 10,000 and a salary of 8,000? That is 2,000, correct? But values are very closer. But at the same, if you check age, let's say I'm having an age of 100 and I'm having an age of 2 years. There's a difference of 98. But don't you think age difference of 98 is very, 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 very higher comparison to the 2,000 difference in the salary? But why the number misguided me? Because of the different scale. एज का स्केल अलग है, सैलरी का स्केल अलग है. हो सकता है एज में 10 वैल्यू भी बहुत ज्यादा हो और सैलरी में 10,000 भी वैल्यू बहुत कम हो. एग्रीड? But once you do the scaling, all the variables come onto the same scale. All the variables come onto the same scale, and clustering does not differentiate any feature on the basis of their scale. हम नहीं चाहते हमारी क्लस्टरिंग किसी फीचर को एक्स्ट्रा वेटेज दे ताकि उसका स्केल हाई है. वी कांट डू दैट. किसी फीचर का स्केल होना उसकी प्रॉपर्टी है. दैट इज नॉट इट्स प्रिडिक्टिव पावर. दैट्स व्हाई. Okay, now let's start with the modeling. So again, importing the library for modeling. Of modeling from sklearn.cluster, we need to import k-means. From sklearn.cluster, we need to import k-means. And then finally, we need to implement the elbow method to find the optimal number of clusters. So 3 clusters we need. It is given in the problem statement directly. Correct? But still, I want to show you how to use elbow method. Okay. So first of all, we are importing that. So now what I am doing, I am just calculating the inertia. So basically, I'm using this elbow method to find the optimal number of clusters. So what I'm doing, I'm basically training the k-means algorithm for 2 cluster to 20 clusters. Again, everybody knows why I'm starting from 2, because minimum number of cluster is 2. But maximum you can go whatever you want to go. Okay, maximum you can go whatever you want to go. Correct? Whether you want to go up to 10 or 15 or 20 or maybe 50, that's up to you. Okay, so I'm training the k-means algorithm fitting on the scale data. So in k-means algorithm only, we are having this inertia method through which we are calculating the error. So we are using the elbow method to find the optimal number of clusters. Although in this problem statement, in industry, in many problem statements, we are already aware about the number of clusters. But still, I want to teach you, even in those 1% of the cases, wherever you do not receive the number of clusters, optimal number of clusters, how to calculate that. So elbow method is one of the method for the same. So what I'm doing, I'm training k-means clustering for 20 models, for 20 up to 20 clusters, starting from 2. Everybody knows why I'm starting from 2, because minimum number of clusters are 2, and maximum you can go up to that. That's up to you, like 20, 30, 40, whatever. But as I told you, generally cluster 10-15 से ज़्यादा होते नहीं है. In any use case, clusters are not more than 10 or 15. 10 or 15 be like is a very higher range. So what I do, I just train multiple clustering algorithms from 2 to 20 on my scale data. And whatever error I was talking about yesterday on y-axis in elbow method, that is calculated from inertia method in this k-means model only. It is already in the library itself. So I am just creating a list of all those error corresponding to every cluster value, and creating a data frame out of it. So I'm creating an error data frame which contains number of clusters and the corresponding error with it, which I have calculated using this method. So this is the data frame. You can see that with number of cluster 2, this is the error. With 3 cluster, this is the error. For 4 cluster, this is the error, and so on. Now let's plot this. So we able to see that first elbow is coming at somewhere here. And which is nearby 3. Agreed? लगभग 3 के आसपास है. And again, clusters has to be unique value, correct? Cluster has to be integer value. It cannot be in decimal, correct? It is the number of clusters. Number of clusters cannot be 2.5 or 3.5. या तो वो 2 होंगे या तो 3 होंगे, correct? Number of clusters cannot be in decimal. So the most nearby decimal value, you can say that it is 3 over here. So optimal number of clusters, from graph also we are able to see 3. And guys, your results and my results may be slightly varied, but बहुत ज़्यादा difference नहीं होगा, but they can be slightly varied. So don't worry on that side. So now finally, let's train the model. Okay, now let's finally train the model with 3 number of clusters. Okay, so we are training the final k-means algorithm with 3 number of cluster on the DF scale. Okay, model got trained, and see, we are able to predict with the help of the model. So I trained the k-means algorithm with clusters equal to 3, and we got the output finally. Okay, and now we can save it. Over to you guys, create clusters. Basically now with the help of predict method, we are able to get the output. And in your original data overall in the starting data frame, I'm adding this output column. Are you guys able to see the in the original data? Are you able to reach till this point? Once you have the cluster added as a new column into your data set, now our job is to figure it out. Guys, my value will be different from you. I have already given a disclaimer that abhi comparison nahi kar. Again the reason is because ये cluster IDs है. वो ID हो सकता है cluster same हो आपका और मेरा, but वो IDs अलग हो सकती हैं. तो don't compare. जब हम इन clusters को नाम दे देंगे, then you should compare. Okay? Once we identify कि 0 क्या है, 1 क्या है, 2 क्या है, then you compare with my results. अभी मत compare करो. Now my question to you guys, tell me among all these features, which feature you think is the best indicator of the growth of the country? In सब में से सबसे important feature, what do you feel? Yes, that is GDP. Absolutely correct. GDP is the most important one. Correct? From the business knowledge, domain knowledge, it is the most important. Correct? Okay, so now let's do one thing simple. SNS dot bar plot. On x-axis, let's use the cluster, and on the y-axis, let's plot the GDP. Correct? I don't want those black lines now. I'm just removing that, and plt dot show. Yeah. So in my case, can I say that 0 is representing underdeveloped country? In my case, you have to check as per your case. 1 is representing developing country and 2 is representing the developed country. Do you agree with me? In my case, 0 representing underdeveloped, 1 representing developing, and 2 representing developed country. Correct? You need to check as per your. आप अपने अकॉर्डिंग चेक करो, वो मेरे से अलग हो सकते हैं. You need to check according to you. And then finally, you need to map them. So for me, 0 is underdeveloped and 1 is developing. This is what for me. 0 underdeveloped, 1 developing, 2 developed. And after that, when I check the head, once you able to map them as per your graph, now your results and my results should match. Again, not exactly match, but slightly here and it should be majorly match, let's say. कुछ के मेरे से सेम भी हो सकता है, कुछ के डिफरेंट भी हो सकता है, guys. Don't worry. Okay? Implement this and compare your results and my results from cell number 32. उससे पहले comparison नहीं करना. Again, currently we just check on one variable. Now we need to validate. अभी हमने एक के ऊपर assumption की है ना. Now we need to validate whether my clustering results are validating on other features or not. So after GDP, which feature you think is a good one? After GDP, income. Income, I would say, guys. Per capita income is one which would be better after than GDP. But again, आप और पे भी check कर सकते हो. That could be subjective call. Okay, income, inflation, both are important. Yes, after GDP, income and inflation. So let's check on income now. So can I say that it is still holding? My assumption is still holding. On income also, for developed country it is maximum. For underdeveloped country it is holding minimum. Let's check for inflation. See, again, this is also holding. Inflation is maximum in underdeveloped country and it is minimum in developed country. So yes. So can I say that my assumptions are validating on all other features as well? Now you can check on others also. You can check now that you are saying exports. See, it is holding on exports also. Now let's check on health. It is holding on health also. Now check for imports. It is holding for imports also. Now let's check for child mortality. It is holding for child mortality also. Now check for total fertility. It is holding for total fertility also. Now check for life expectancy. It is holding for life expectancy also. See, it is holding for each and every feature. But again, in industry, it is not necessary कि सारे features पे hold करे, but it should hold on top 4-5 features at least. Okay, but यहाँ पे सब पे कर रही है, that's a good thing. But if your clustering is holding on top 4-5 features or most important 4-5 features, then you are good to go. So now what do you need to do? The last step of evaluation, let's validate. Let's validate with the country name. So let's say I'm making the cluster developed one by one and just look at the country, creating a list out of it. Now just use your geographical knowledge and your international knowledge. Don't you think all these are definitely other developed countries? See Australia, Austria, Belgium, Canada, Denmark, Finland, France, Germany, Greece, Iceland, Ireland, Italy, Japan, Kuwait, Netherlands, New Zealand, Qatar, Singapore, Switzerland, UAE, UK, US. Yes, these are developed countries, correct? If we use our domain knowledge, similarly, you can check for underdeveloped. See, Afghanistan, Angola, Burundi, Cameroon, Chad, Comoros. See, these are the African countries, and we know that African countries are underdeveloped, correct? Same, yes, exactly, Samir. Same here. Mostly African countries are underdeveloped. We know that. Same here, see? Pakistan coming over here, Rwanda coming over here. Mostly African countries are underdeveloped. And same you can check for developing. See, all these are the developing countries. And India is there. See, these are the developing countries. Please check for these results at your end and validate whether they are matching with your geographical and your knowledge or not. Okay, one by one, validate that. This is how we validate clustering results because we do not have the ground truth. So we use domain knowledge to validate the same. So let's check for United States. Okay, let's take Russia and let's take India. देखते हैं कि रशिया के पैरामीटर्स, let's say रशिया के numbers are closer to India और रशिया के numbers are closer to US. उससे we will get an idea. See, so we can see that Russia is far better than India in terms of numbers, but it is not that good it able to come into the developed country range. Are you able to see that? We can clearly see the difference in all three of them. Russia के numbers are means numbers are not wrong. Numbers गलत नहीं है. And yes, inflation is also one of the parameters. See, and again you see that inflation हमने second most important variable माना है during the validation. So inflation is a good feature and वहीं पे देखो break हो रहा है. Inflation is more than India. So because of all these situation, there might be some here and there. Okay, so this is all that we are having, guys. I hope you must have enjoyed this session. You get chance to learn and implement the end-to-end problem solving with clustering. So we not only implement the clustering, but we also able to understand why are we doing and what are we doing. So this is all that we have. I hope you must have learned something new, something interesting, and something really good.
If you found this video helpful, then make sure you hit the like button. The YouTube algorithm will recommend you more. And if you don't want to depend on YouTube, then check out the description for more such in-depth machine learning courses.